Hello and welcome to another video. In this problem we're going to be continuing on with the Typescript line 75 and we're going to be doing reverse linked list. So here you're given the head of a singly linked list, you want to return it, or reverse it, and then you want to return it. So in this example, it's reversed. So essentially this is the same thing as you take every single next pointer and you flip it around, right? So let's just draw out these nodes and kind of show that. So if we draw it like this, let's get some more space. So if we have all these next pointers, all of these here, it's essentially the same thing as taking them and reversing them, right? So this is equivalent to this. 5, 4, 3, 2, 1, it's just drawn another way. So essentially what you have to do is you have to take every next pointer and flip it. And how do we do that? So let's go over that. So let's start with our original list, like this. And let's just get rid of some of these arrows. Yeah. Let's get rid of this, get rid of this, get rid of this. Okay. And now we will draw it this way. But yeah, essentially we have to just figure out a way how to reverse all of these. And so if you think about it, you can't just traverse backwards and reverse them, right? There's like, you can't traverse a list backwards. So you have to figure out a way how to traverse forwards and reverse these. And this is like an algorithm that you should know, so I'm going to go over it. So what you need to do is you need to have 2 nodes here. Actually, you're going to need 3 nodes. You're going to need to have a current node that starts at the head and keeps going. You're going to need to have a previous node. And then essentially what you really want is you want current to point to previous, right? Like this needs to point to none. It doesn't show it in the picture, but it should, right? So like this 5 actually does point to none. But the problem is if I just like take this, right? If I just take this and have it point over here, then how do I get here? I can't. And so what you need to do before you do that is you need to actually set a node to be the next pointer of the current node so that way you can traverse later. So what you need to do is you need to make a temp node and you need to make it the node after the current node. So we make a temp here. Now we can make current point to previous. So current will point to previous. Now what you have to do is you just have to make previous equal to current. So we can actually write all these steps down. So make temp node equal to current.next. Make C point equals previous. Then make previous equals current, and finally make current equal temp. So let's kind of like follow this procedure. So we did these first 2 things, right? We made current.next equals previous. Now we have to make previous equal to current. So this previous is going to move up here, and this current will be the temp over here. Now we kind of have the right thing, right? And so let's do this again. Essentially. So we have to make a temp node that's equal to current.next. So we're going to do that. We're going to make a temp node over here. Now we have to make current point to previous. So we can do that. Point to previous. Now we have to make previous equals to current. So previous is here. And finally we have to make current equal to temp. So we did that. Now let's keep going. So we make a temp equal current next over here. Then we make current next equal previous. So get rid of this. Then we make previous equals current. And finally move current up. And this temp should have been gone because we made a new one. Okay, now we keep going. And we keep going until current is out of bounds. So we have a few more. So make temp node over here. This one's gone. Make current next equals previous. Let's actually draw this. Now we have to make previous equals current. So previous is over here. Now let's actually draw it like this. So previous equals current. And now finally, let's make current equal to temp. So this current is going to move up over here. So it's still in bounds. So now we do it one more time. So make temp current.next, which is over here, right? Because this is pointing over here, really. Now you have to say make current next equals previous. So this is going to be like this. Now we have to make previous equals current. This temp was gone. And then finally, you have to make current equal to temp. So now our current's out of bounds, and now we have like the right thing, right? This is our reverse list. So once our current is out of bounds, what's going to happen is previous is actually going to be the new head of the list, because you essentially reversed your pointers, and now previous is going to be the new head of the list. So now, finally, once current is out of bounds, we just return that previous node. And that's pretty much all you need. So you need a previous node that's going to start out behind the current node, right? It's going to initially be null because you want your original head of the list to point to null, right? Like no matter what list you have, when you reverse it, that's going to point to null because you're going to have a list going this way. So this head node should point to null. And then finally, you move them both up, and your previous is going to be the head of the new list, and you simply return that. So now we can code that up. So now let's actually code this up. And we are going to use a few tricks for TypeScript for this that are going to be kind of convenient, and we're going to not have to make a current and a head, or not a current and a temp variable, and I'll kind of show you how that works. So we are going to make this previous, so we're going to say let p, and it's going to be type of list node or null. So we're going to set that equal to null, right? It needs to start off as null. Now remember, we had a temp that was cur next, and then we had a cur. So we can actually use the head as the cur because the head starts at the start, and we'll just go to the end. So we're actually going to use the head as the cur, and then we're actually going to use destructuring to not have to use a temp, and I'll show you how that works. So essentially what we're going to say is we're going to say while head, which is head is basically what that current variable was. So while the head is true, let's actually go through, I don't know why I did that. There we go. So we can actually do a destructure here. So essentially what we want is we want three things, right? So let's write down these three things. So we want the head to equal head.next, and we want head.next to equal this previous node, and we want previous to equals head. But we need all these to kind of happen. Ideally we want to calculate all these values, because remember, if we do head equals head.next, after we do this, let's say, then head.next is actually pointing to p. So ideally we want to calculate these three things and then store them and then reassign the values. And so we can actually do that by doing a destructuring. So we can say head.next, and then we could say head and p equals, and by doing the destructuring, essentially what's going to happen is all the calculations on the right side will be done and saved, and then they will be put into the left, so we can actually avoid having the temp variable. So we want head.next to equal p, right? Then we want head to equal head.next, and we want p to equal head. And so basically what's going to happen is you're going to get all of these values. So the current p in this situation is actually null, so head.next will be null. Then head will be head.next, and head.next in this snapshot is actually over here. And then p will be head, but head in this snapshot was 1. So essentially you take a snapshot of all the current states, and then you reassign them. That way you don't have this issue of like trying to make things equal to things that are no longer the case. So you store all these three values, and then you reassign them. And now we can simply return p here. And I think that should work. So let's give that a go. So this is kind of like a cool TypeScript thing you can do. And you don't need to make a const or a let because you're not declaring any new variables. You're basically just reassigning. So you're not making a new array. This is literally just destructuring. So let's take a look here. And you can see this does work. And as far as efficiency, it's about the same as the other one, right? It's like all over the place, but it's just like a cool way of writing things that is kind of convenient if you don't want to make like a temp variable or something. So let's go over the time and space for this one. So the time we are looping through our linked list, so that is just O of n, and the space is O of 1 because we are just using this p and we're reusing the head, and yeah, so we're only using two variables. We're using head and p, and that's pretty much it. And yeah, if you think this is a bit confusing, you can definitely do the things that I said in the picture where you make a temp variable and then you make like all those steps. Like that would totally be fine as well, but this is just like a cool way of writing it, so I just wanted to show that one. And yeah, it's gonna be it for this problem, so hopefully you liked it. And this is one that you do need to know for a lot of harder linked list problems, so this is like a must know for sure. So definitely be able to do this one like automatically, because this is going to be like a sub problem of all the, not all, but a lot of the harder problems for linked lists. So yeah, that's going to be all for this one though. And if you like this video, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.